Okay, welcome back. Last one we're going to look at for finding zeros anyways. So again, ask yourself what form you're in. This one's actually partially factored form. Now, again, as to remind yourself what this is actually telling you, the values from the brackets here, the x equals 4 over 3 and x equals negative 2, these are not zeros, okay, because of that minus 8 that's hanging around. What this is actually telling you is two symmetric points. So you'd have a point at 4 over 3, negative 8, and negative 2, negative 8. Now, none of this helps us here, but just to remind yourself what partially factored form does, it would give you 2 points with the same y value right here, since these are both at negative 8, so you could use these two x values to find the axis symmetry. Now, again, none of that's useful here, but just remind yourself that's what partially factored form is telling us. What we actually need to do here, if we think back to our flow chart, we have partially factored form. What we probably want to do here is expand it and simplify using an array, put it into standard form, then we can have a whole bunch of other tools at our disposal. So let's give that a try. I'm actually going to let you try that one on your own. So put this into standard form, expand it and simplify, and then use whatever the appropriate method that you think is best to find the zeros from there. So pause it for now and push play when you're ready to see the answer. Okay, so that everything is. So again, just to recap, first thing I did is I took 3x minus 4x plus 2, threw it into an array, multiplied, collected my like terms. I got 3x squared plus 2x minus 8 coming from there, and of course carried down that minus 8 that was part of the original equation to begin with. Simplify it into 3x squared plus 2x minus 16, and then again my options are to factor if possible or use quadratic formula. I did what I did before. Check the discriminant, b squared minus 4ac, it gave me 196. Square root of 196 is 14, so it's a perfect square, therefore it factors. And I don't know about you, whenever I discover I can factor instead of using quadratic formula, I'm always happy, so, little smiley face there. So from there I went to go factor, so threw 3x squared minus 16 into an array, made 2x with 8x minus 6x, so we factored into 3x plus 8 and x minus 2. So that gives me my factored form right here for f of x, and then I'm very, very happy because then I can just do some quick little algebra here to get my 2x intercepts. So 3x plus 8 equals 0. Solve that, tells me that x equals negative 8 over 3, and this tells me that x equals 2. Okay, so there are my two zeros there, and I'm done. Alright, so that's enough of finding zeros. Let's just try and recap now how we find axis symmetry. So, again, we'll go through different examples of this on the slide after this, but if you're in factored form and you get your zeros, you'll remember the axis symmetry is that x value that cuts the parabola in half, so it's going to be halfway in between your two x-intercepts. So if your two zeros are x1 and x2, you can add them together, divide by 2, and that will give you your axis symmetry. X equals. So x equals x1 plus x2 over 2 if x1 and x2 are your zeros. So if you're in vertex form, it's even easier because the axis symmetry should be staring at you in the face. It should be the h value in the equation, and we'll see that in the next slide. Standard form, again, you have a whole bunch of options. If you can factor it, then you can do what we would normally do and average the two x-intercepts. If not, you can partially factor it and get the x values from the symmetric points. Or we can find some way of putting it into vertex form using completing the square. And then in vertex form, we could, again, get the x coordinate directly by looking at the equation. But lots of options, again, once you're in standard form. So let's take a look here, some examples. So here's 8 different quadratics. I want you to figure out which ones have an axis symmetry at x equals 2. Try and take a few minutes, try and figure out as many as you can on your own, and then we'll take them up when you're ready. So just pause it for now. Cheers. Okay, so I'm actually going to start with ones in vertex form. Those are the easiest ones to work with. So first one here, this third one, negative 5 bracket x plus 8 all squared minus 6. That's in vertex form, so the axis symmetry is right there. That's the h value. So in this case, the axis symmetry is negative 8. So this is not one of the ones that we want. Okay, so if I were to pop this one, it wouldn't be one that would be right. So this one has an axis symmetry at negative 8. So looking at the other ones in vertex form, we have the one down here. This axis symmetry is actually at negative 2. So this would be one that would be wrong. The one over here, though, looking at, again, in vertex form, the h value is positive 2, so this one should be correct. So I'll pop that one, and there we finally have one that works. Alright, so let's take a look at the other ones now. Let's work with the factored form ones now. So looking at this first one up here in the top left, the negative bracket 3x plus 1, 3x minus 13. So in factored form, we can get the x-intercepts. So this one, you'd have 3x plus 1 as your first bracket, set equal to 0, solve for x. So 3x equals negative 1, x is negative a third. For the second one over here, 3x minus 13. So if you solve for x, you're going to get 13 over 3. So for your axis symmetry, you're going to take these two values, add them together. So you're going to get negative a third plus 13 thirds all over 2. All over 2. So when you do that, I'm running out of space here, but negative a third plus 13 thirds is 12 over 3, which is 4. So you get 4 over 2, which simplifies down to 2. So this one gives you an axis symmetry of 2. Down here, same idea. Your x-intercepts in this case are going to be 8 and negative 4. So for your axis, you go 8 plus negative 4 all over 2, and that looks like gives me 2 as well. Okay, into partial factored form here. So what this is telling me, again, I'm not being given the zeros here, but I am being given two symmetric x values here. So what this is telling me is I have points at negative 10, negative 7, and 6, negative 7. Even though these aren't zeros, the fact that both the y values here are the same at negative 7 in this case, it means it doesn't actually affect us in terms of finding the axis symmetry. So we can go negative 10 plus 6 divided by 2 to find our axis. And this one actually winds up being negative 2, so this one won't work. Okay, last but not least, you got the two left from standard form. Just make some space here. Okay, so from standard form, our options are we can try and factor it to find the zeros. Now, if you take a quick check of the discriminant here, you're not going to be as happy with this one because if you do that, 3 squared minus 4 times negative 4 times negative 2. If you check that in your calculator, that's going to give you negative 23. So not only is it not a perfect square, it's actually negative, so this one actually has no zeros whatsoever. So not even using quadratic formula will help you get the zeros. You have to find a different method here. So one option is we could try and complete the square to put it into vertex form, though we probably didn't do that too much in grade 10. We'll have to review that later on in the unit. The other thing we can do is a little bit easier, because again, all we're looking for is the axis symmetry. We can do some partial factoring here. So to partial factor, and it might be something that you didn't do tons of last year, what we're going to do is we're going to take a look at just our first two terms here and just take out whatever common factor we can. So between these two terms, the coefficient have nothing in common. I mean, I'm going to take out the negative just to make it simpler to look at afterwards, but they both have an x in common. So I'm just going to take out an x, well, negative x technically, and I'm going to be left with 4x minus 3, and that minus 2 is going to hang around. So in one step there, I'm in partially factored form. Again, what this is going to tell me here is that I have two symmetric points. One from this bracket here, this is going to be a point at 3 over 4, negative 2. And one from over here, that's going to be at 0, negative 2. Again, not the zeros, but all that matters is I can now use those x values to find my axis symmetry. So once I have those, I can find my axis going 0 plus 3/4 all divided by 2. and whatever that is most definitely not 2, so this one will not work. Okay, and we can try that exact same process with this last one. Now, this last one, if you try to factor it, I don't believe this one factors, and if you check the description, it's not a perfect square. Quadratic formula will give you the zeros, which you could then use to find the axis symmetry, but this partial factoring actually doesn't take very long, so let's try it with this last one here as well, just so we can see how fast it is. So I'm going to take my negative 3x squared plus 12x minus 10. Okay, and again, just to remind myself, I'm going to leave that constant alone and just take a look at my first two terms and common factor them. So between negative 3x squared and 12x, they both have a negative 3 in common, and they both have an x. What's going to be left over? Just going to have x minus 4. That minus 10 is going to hang around. So one step, I'm in partial factored form. Remind yourself, this tells me I have 2 points. One point at 4, negative 10. The other point at 0, negative 10. So my axis symmetry will be halfway in between these two x values right here. So halfway between 0 and 4, you can probably see relatively quickly that that's going to be 2. So this one fits what we're looking for as an axis symmetry of 2. So there you have it. A lot of grade 10 quadratics thrown back at you all at once. There's going to be more to come over the next couple of days, and hopefully we didn't hurt your head too much on day 1. Okay, there's your homework to give it a try, and let me know, of course, if there's anything that goes wrong with it. Thanks a lot. Cheers.